And we'll go now to the second presentation by Sam Kosa, who is talking about a pre-designed pile test program and what we can learn from that. Sam, the floor is yours.
Good morning, everyone. I'm here to talk about pre-designed pile test programs. I'm going to discuss 3 of them. These were all performed in advance of the design for the projects. And as a result, there was a value engineering that was accomplished. Okay, the advantages of a pre-designed program are probably pretty obvious. Of course, there's a potential in piling cost savings, more competitive bidding among your contractors. And it should also expedite the construction schedule. And another big item is reduce subsurface soil unknowns that could happen during the actual construction project. Value engineering advantages, pre-conducted test pile contracts would improve mainline operations, improve local operations, improve maintainability, reduce construction impacts. A big one is reduce the environmental impact, and of course, shortening the project schedule. And it takes away a lot of the risks by the contractor. The first project I'm going to talk about is the light rail pre-designed test program at JFK International Airport. There were 3 sites within the airport. Site A was at the Federal Circle area. Site B was at the Howard Beach area, and Site C was the Central Terminal area. This graph shows basically a summation of how the piles performed. What we have in red is a tapered friction pile that was used, and in blue we're showing an 18-inch 3/8" wall pipe pile, which is closed end. There were 3 pile types tested: the pipe and 2 of the friction tapered piles. One type was monotube, the other type was taper tube. This graph shows that the soil conditions were filled over an organic layer, then followed by medium to fine sands and silts, basically down to depths well over 100 feet. The chart to the right shows a pile hammer blows per foot. It's color coordinated, and the red indicates the tapered pile driving, and the blue, the pipe pile driving, pile counts. As can see in the lower right, the load test, static load test results up to a 450 ton compression capacity. The tapered piles had considerably less settlement than the pipe piles, and but they both carried at their respective depths of 52 and 101 feet, close to the 450 ton ultimate capacity. Evaluating the pile drive logs, looking at the 18-inch diameter tapered friction piles, you have a pile that is basically 52 foot long. It took 927 blows to install this pile. The driving time figuring the Yuntan hammer was functioning at 34 blows per minute, driving time was 27 minutes. And the piles were shipped to the site at 65-foot length. So there was the length of 52 feet being less than the 65. We ended up with no field splicing. And we show that based upon 27 minutes to drive the piles in an 8-hour shift, we could probably get 17 piles driven in a day's work. The pipe pile, in comparison, showed at 101 feet that it took 1,991 blows, or converted to 59 minutes of driving time. Since pipe is delivered to the job site in 40-foot lengths, it required 2 splices, each splice actually calculated at 29 minutes from the drive logs, indicates that a total drive time for this 101-foot pile was 1 hour and 57 minutes, or in an 8-hour day, we only could get 4 of these piles in the ground. Besides that, there was a considerable savings in the amount of concrete that you can put in each pile. The summation is that with a pre-designed test program, you can get a lot of valuable information as far as the pile performance, the pile costs. A lot of information can be resulted from, and your piling contractors, your general contractors, they can look at all this data and use it to put their best foot forward in the bidding process. The next project to talk about is the Lafayette Bridge Replacement pre-designed test program in St. Paul, Minnesota. This particular bridge resulted in several test sites. Indicated here, test site A was on the south edge of the Mississippi River. Test sites B, C, D, and E are on the north side of the river, both these within the city of St. Paul, Minnesota. Subsurface soil information from 0 to 60 feet. It was a brown coarse sand with some gravel, and a 60 to 140 foot range, the color changed to gray, and it was still coarse sand, and it was actually saturated. At 140 feet, they had a sandy dolostone, slightly weathered rock. There were 18 test piles. This chart shows a summary of 8 of the 18 test piles. The 2 H piles that were driven were HP 12 by 53 and HP 14 by 89. They were both basically 140 to 142 feet. And depending upon where they were driven, cap-wrap ultimate capacities were in the range of, went from 185 tons up to 354 tons. Pipe pile was 16-inch OD with a 1/2-inch wall. Its lengths were 92.5 feet, 111 feet, and they had ultimate cap-whack capacities of 375 and 444 tons. The tapered friction pile was a 16-inch OD pile with a 33-foot taper. It performed at lengths of 66 and 73 feet. The 66-footer had a cap wrap of 207.5 tons, and the was performed under a static load test of 247 tons. There were 2 concrete pile types installed at this site. It was more of an additional situation just to see how concrete piles would perform in this area. And it was a 57-footer and 106-footer. And these were basically 118 CAPWAP results, tons, and 186.5. The installed pile pricing was obtained from contacting 3 different contractors who aided us in computing the costs based upon their figures. They had installed prices of for H piles, pipe, and friction piles. And on the average, the H pile, the smaller H pile, was estimated to cost over $36 a foot installed. The 14-inch H pile, slightly over $58 a foot. And the pipe pile at just over $73 a foot. And the tapered pile, just over $58 a foot. The concrete pile was estimated at, by the one contractor, an average price of $27 a foot. The next project to discuss is the Milwaukee Park in Miller Park rather, in Milwaukee, Wisconsin. It's of course, a baseball stadium. This project was anticipated to be constructed at a site opposite the expressway from the existing county stadium. The test piles at this site were 16-inch diameter tapered piles, 12 3/4-inch pipe piles, closed end, 13 3/8-inch closed end used oil casing, HP 14 by 89 H piles, and 5-foot diameter drilled piers, rock socketed. As discussed, this particular project was tested on the east side of Route 172. And as a result, this graph shows the results of that test that show the cost per ton supported of the various types of piles. And as can be seen, relative to depths, we have a situation where they range from $14.17 per ton supported to $17 per ton supported. There was a big advantage, however, in the rock socketed piles. We end up with the price down lower than $10 per ton supported if the piles were under 50 feet in length. The problem is the site is much deeper. The rock is up to over 200 feet at this side of the expressway. So it was decided, well, let's consider moving the site to the west side of the expressway, where the rock varied from 30 to 130 feet. The result was that this graph shows in yellow that the rock socketed was economical to lengths of about 90 feet. And then the tapered friction pile for pile lengths greater than that we would end up with a situation that the friction pile taper would be more economical. What happens is when evaluating how the taper would work, you can't stop the taper at the rock. There has to be a certain amount of soil beyond the tip of the taper. So there was a decision made that tapered piles would be used to depths of approximately 70 feet, from 70 feet and longer, and the rock socketed piles would be used for depths of 70 feet and shorter. This resulted in, if you were to draw a line from first base to third base on the site, back to behind home plate, those would be rock socketed piles, and those beyond the infield into the stadium's construction would be the tapered piles. So the advantages of the Miller Park test program recognize that the new stadium would be more economical if it was built on the west side of the expressway. And it actually ended up with two pile type solution. Additional pile capacity due to soil setup was realized in the tapered pile, which really resulted in a 200-ton design load pile, which was originally estimated to only be a 150-ton design load pile. It shortened construction schedule, and it also reduced the subsurface soil unknowns, obviously. Thank you for your interest, and I hope this was of value to you in recognizing what a pre-designed test program could equate to a project.
Okay, thank you, Sam, for your presentation.